Hello everyone, in this video we'll be predicting the outcomes in the porous pot experiment. In this video you will learn what's the concept behind the porous pot experiment, as well as to predict the outcomes of the porous pot experiment. But before you watch this video, you must have already mastered how to compare the rates of diffusion in the different gases. So this is the porous pot, right? The porous pot is the part that I'm pointing to now. This is the porous pot, right? And porous meaning that gases can flow in or gases can diffuse out, all right? And what's happened is that there is one gas that is outside the porous pot. So in this case, we have air, right? And there will be a gas that's inside the porous pot, and in this case, we have carbon monoxide. Okay, so what happens is that depending on the rate of diffusion, let's say the gas outside diffuse in faster than the gas inside diffusing out. So the gas keeps going in. So this will cause the gas to push and push and push, and causing this water level at Z to go down. Let's say if the diffusion goes in fast, right? And this will cause Z to go down. Now, what happens if it's the opposite? So let's say, for example, the gas goes out faster than the other gas coming in. So it will like suck up like a straw, right? It will suck up the gases in, goes this way, you follow my arrows, right? And at Z, the water level will go up. So this doesn't happen permanently. After the Z level, water level there goes up for a while. After a long time, after the diffusion happens for a long time, the water level at Z will go back down. Okay, so what you have heard so far is that it depends on the rate of diffusion of the gas outside the pot and the gas inside the pot. Okay, so let's look at this first example here. Please take down notes for you to remember. We have hydrogen, which is H2, outside the pot, and we have carbon dioxide, CO2, inside the pot. So firstly, we need to compare the rates of diffusion. We need the relative molecular mass. Hydrogen has a relative molecular mass of 2, while carbon dioxide has a relative molecular mass of 44. Right? That being said, hydrogen will diffuse faster than carbon dioxide because it is lighter. So hydrogen diffuses in faster than carbon dioxide diffusing out. So hydrogen diffuses in much faster than carbon dioxide diffusing out, like this. So that means there's an overall going in the porous pot. And when it goes in the porous pot, the gas particles are being pushed this direction, and then the water level at Z will go down, and the water level at X will go up. Alright, so that's how it looks like in this example. Let's try another example. Okay, now we have carbon monoxide inside and we have air outside. And now we know the air is approximately 78% nitrogen. Therefore, the RMM of air is slightly more than 28. Okay, and then the RMM of carbon monoxide is actually 12 plus 16, which is exactly 28. That will mean the air is slightly heavier than carbon monoxide. And because air is slightly heavier than carbon monoxide will diffuse faster than air. So carbon monoxide will diffuse out faster than air diffusing in. And if carbon dioxide diffuses out, it's like sucking on a straw. So the gas particles will go this direction, causing the water level at Z to go up. So I want to emphasize that it's very important for you to draw these arrows so that you can visualize which direction the water level goes. Okay, one last example. So let's try the next one. Oxygen outside and carbon dioxide inside. The next step, oxygen has a RMM of 32, carbon dioxide has a RMM of 44. Lighter gas diffuse faster, so arrow points in. Oxygen diffuse in faster than carbon dioxide diffusing out. So oxygen diffuse in faster, you see my arrows? You must draw your arrows, then you can see it goes in, and then at level Z, the level will go down. Alright, so we must be able to predict, right, the result of this experiment, and you will need more practice. So please practice, and I hope you get better. Alright, bye bye.